The following is a discussion of the theory behind the method of planes as implemented in the Uplift program. This theory and these figures that are used herein can be found in a thesis written by William Caver for the University of Mississippi. The sliding mass in the method of planes is divided into three zones: an active wedge, a sliding block, and a passive wedge. And equilibrium equations are generated for each of these three zones in order to determine a driving active force, a driving passive force, and resisting forces from the active wedge, from the sliding block, and from the passive wedge. In terms of the active wedge, a free body diagram is drawn and a force diagram is generated, and the driving active force and the resisting active forces are both resolved into vectors acting in the horizontal direction. The magnitude of the driving active force is given by this equation, and the magnitude of the resisting active force is given by this equation. In terms of the central block, the sliding block, the resistance to sliding is provided both by a cohesive component and a frictional component if both are present on the slide plane being considered. And in terms of the passive wedge, a free body diagram is drawn for the passive wedge, and the driving passive force and the resisting passive force are both determined from a force diagram.
Here we have 2 pages from the Corps of Engineers design manual for the slope stability calculations associated with levees, T-walls, gates, and I-walls. The first portion of the table presents the analysis condition and the required minimum factors of safety for each of the various conditions. I've highlighted or underlined the areas relevant to T-wall design. The criteria that we check for T-wall design when running a Spencer's analysis is the still water condition, the condition for water at the top of the wall, and the condition for low water level, both during a hurricane and without a hurricane. With the method of planes is used as a check against the Spencer's method and to benchmark for the older design procedures that were used historically. And for the method of planes, the only 3 conditions that we check for a T-wall design are the still water level, the top of wall, and the low water level hurricane condition. There's a few more details, and you can look at the individual pages in your downloaded version of the manual. But for the still water condition, we assume that the strengths that we're going to use for clays are going to be the Q strengths, or the undrained strengths, and the strengths used for the granular materials are going to be the drain strengths. The still water level is established by a hydraulic engineer and given to the geotechnical engineer for the design. The top of wall is self-explanatory. That's for flood water at the top of the wall. And the low water level condition during a hurricane is also given by a hydraulic engineer to the geotechnical engineer. As I mentioned earlier, the method of planes is only used as a design check for the Spencer's method, and in the case of the non-hurricane condition, the method of planes is not used at all for that particular criteria.